Alright, problem 6-103. Solve each system of equations below. So a little bit of practice here with our systems of three equations. First one, we have negative 4x equals z minus 2y plus 12. Second one, y plus z equals 12 minus x. And the third one there, 8x minus 3y plus 4z equals 1. What I'm going to go ahead and do here is make this so it's easier to compare them. I'm going to put them into standard form. I'm going to get all my x, y's, and z's on the same side. Remember to do that. You're just doing your inverse operations to move things. So I already have a negative 4x on the left side here. I'm going to do letter A over here. So I'm going to say negative 4x. And if I took it and I added 2y to each side, I'd have plus 2y. And then I'd have to subtract a z from each side, so I have minus z equals 12. Second one, to get x, y, and z on the same side, I'm going to have to just add an x to each side, so I'm going to have x plus y plus z equals 12. And the third one here, 8x minus 3y plus 4z is already ready to go, so we just put 8x minus 3y plus 4z equals 1. Now we got our system here. We're going to figure out what variable we want to start out eliminating. That way we can break it down into a system with two variables to help us solve it. I'm going to number these just to make it easier. Let's see, let's make this number 1. Let's make this number 2. We'll make this one number 3. So I think I'm going to start out with 1 and 2 because that's pretty easy. I can get rid of my z's, and then I might use, let's use 1 and 3 for our second pair. So here we go. I'm going to put negative 4x plus 2y minus z equals 12, and then x plus y plus c equals 12. Let's get ready to eliminate here. So as we're eliminating, I'm going to switch my pen. It keeps switching back to thick, and I apologize for that. It's harder to read that way, I know. We're looking at these two terms are going to cancel each other out because those are additive inverses. So we should end up with a negative 3x plus 3y equals 24. Don't write 12 down there. I know somebody's going to. So we've got that equation. Let's do 1 and 3 here. So I'm going to say negative 4x plus 2y minus z equals 12. And before I do anything further here, just because I'm going to have to keep writing things down there, I'm going to want to change this into a negative 4z if I wanted to cancel out with my positive 4z. So let's go ahead here and multiply both sides of this one just times a 4. And that will allow us to do our elimination. So let's do 4 times negative 4 is negative 16x plus 8y minus 4z equals 48. And now let's recopy the third one down here. We'd have 8x minus 3y plus 4z equals 1. So hopefully you followed along there. I just changed this one here before I wrote everything down, so I didn't have to write everything 2 and 3 times. Now we know that these are additive inverses here, so the sum of those is 0, so they are gone. Negative 16x and 8x is negative 8x. 8y and negative 3y would be plus 5y. And that should equal 49. There is our second equation. Now we can look to solve these using whatever method we wish to use. If you're going to do elimination, you're going to have to alter both of the equations. If you're going to do substitution, I would look to probably get x or y by itself here, because all of these numbers are divisible by 3. Which one's going to be easier? Just depends on what you wish to do. I'm going to go ahead here and let's do elimination. I like elimination, it's my favorite. I'm going to eliminate, I'm going to eliminate my y's. I'm going to eliminate y's. So what number does 3 and 5 both go into? Well, that would be 15, right? So I'm going to need to make this into a 15y and make this one into a negative 15y, or vice versa, whichever way you want to do it. So I'm going to do this one as my negative 1. I'm going to multiply this entire equation by negative 5. So negative 5 times negative 3 is going to give us positive 15x. Once again, it's switched on me again. Minus 15y. And then 5 times 24, well 5 times 20 is 100, 5 times 4 is 20. So we have negative 120. This one here, let's take it here and let's multiply it by, we want it to be a positive 15. So let's multiply it by positive 3. And it's switched again. Love technology, it's awesome. So 3 times negative 8 is negative 24x. 3 times 5 is plus 15y. And then 3 times 49, well 3 times 50 is 150. And we take away 3, that would be 147. So negative 24x plus 15y equals 147. Let's eliminate our y's here. 15 and negative 24 give you negative 9x equals, and the difference between negative 120 and positive 147 would be positive 27. So x ends up being negative 3. Now let's get our y value here. Let's use that negative 3. Come up with our y value, let's plug it in. Let's do, let's just go ahead and use this equation. So negative 3 times x, or negative 3, plus 3y equals 24. So this is where we're finding y. Nine plus 3y equals 24. So 3y has to equal, was that 15? So we divide by 3, y equals 5. All right, almost there. So we have negative 3 and 5 for y. Let's plug that into the equation x plus y plus z equals 12 to get our value of z. So negative 3, hold on, we are finding z here. So negative 3 plus 5 plus z equals 12. Well, negative 3 and 5 is 2. Subtract 2 from each side there. We should get z is equal to 10. So our solution that we're looking at is negative 3, 5, 10. We'll write it up here. Negative 3, 5, 10. Now, remember, this means that these 3 planes intersect at one point. This one unique point is where all 3 of those planes will intersect each other. Can we check it? Yes, we could check it, and we could plug in each of these values in for x, y, and z in the other 2 equations here to make sure they work. However, for time's sake, and since we have a whole nother problem to do, I'm not going to do that there. I'm going to tell you that is correct. I know that that is the correct answer for this problem. Let's look at B now. B, you've got 3x plus y minus 2z equals 6, x plus 2y plus z equals 7, and 6x plus 2y minus 4z equals 12. So with this one, it looks like we've already got them in standard form. I'm just going to recopy them. You should have copied them onto your paper if you did not. It's always the first step. Now there's a couple approaches that can be taken here. First of all, I'll just number these so you know which ones I'm referring to, just like on the other problems I've done. We can take this and make these easier to solve by setting it up there, solving for whatever we want there. We could do y's, we could do x's, we could do z's. It's up to you. One thing I notice here on this one is these are all even numbers, and you don't always have to multiply everything times something. Sometimes you can go ahead and divide, and I'm going to do that on this one just so you can see what happens. Let's look here. Or you could say here we're going to multiply this one times a 1/2. That way, you're staying consistent with whatever your rules are. We're going to multiply everything here by a 1/2. That way I can get my my value here down to where I've got something that might be interesting. Let's see what I'm talking about here. So 1/2 times 6x is going to give me 3x. 1/2 times 2y is going to give me y. 1/2 times negative 4z is going to give me minus 2z. And then 1/2 of 12 equals 6. If you look up here at the top, we have 3x plus y minus 2z is going to equal 6. We've got x plus 2y plus z equals 7. And I'm sorry, it's a big marker and it's not as legible. Well, if I was going to choose some to eliminate here, what would I do? Well, I could say these ones would be good ones to start out with because I could eliminate my whatever I wanted to. And then I could do, say, these two. Let's look, though, at that first pair. If I said 3x plus 3y minus 2z equals 6, well, this one here, let's take it here and let's act like we're multiplying it times a negative, just to flip all the signs. We should end up with, I'm going to do that, keep it in black, negative 3x minus y. I think I recopied this one wrong, didn't I? I did. Plus 2z equals negative 6. So let me fix that there. Glad I caught that. Ooh, let's undo that. Technology is great. This one was supposed to be just plus y. Thanks for pointing that out. Hopefully you noticed that. So when we go to eliminate here, what happens? Well, we get 0 equals 0, which means what? This is the same plane. 1 and 3 are the same planes. Okay, so if those are the same planes, we're not done yet though. We're not done. We still need to think about what our other two are going to end up giving us here. So let's use 1 and 2 now. Let's do 3x plus y minus 2z equals 6. And the second one there, let's go ahead and multiply it just so we can eliminate. Well, it really doesn't matter what we eliminate now, right? Because we eliminated everything in the first one. So since we have a positive z and a negative 2z, let's just go ahead and multiply that one times a 2. So we'll multiply this one times a 2. So we're going to have 2x plus 4y plus 2z equals 14. And now let's go ahead here and we're going to do, these are going to cancel out. There's our 0. We've got 5x plus 5y equals 20. What we're going to see here is, since the other two canceled out, and when we went to solve this one, it didn't all cancel out, what we're going to have to do here is we're going to have to think about this as our intersection point is going to end up being a line. And what line is it going to be? Well, let's take it here. You could say it was this line in standard form, or you could say 5y is equal to negative 5x plus 20, divided all by 5. We get y equals negative x plus 4. So these two planes should intersect on this line. But what is the solution? Well, how many points do we have on a line? Right? There's an infinite number of points on a line. So in this case, we're going to end up with infinite solutions. And I think I just answered the last question there, I'm sorry. It says, what does the solution part B tell you about the graphs? Well, two of them are the same plane, and they intersect that other plane in a part that would create a line. So what you'd be thinking about is this. You've got two of them are the same. So we can say that's like the two that are the same, and then we've got some more here that intersects. And pretty much the intersection is going to be this line here. And actually, I'll make that. So if you think back to geometry, how two planes can intersect each other there, they intersect in a line. That's what we're talking about here. So these two planes intersect in a line. There are infinite solutions. Oh. That is what we're talking about for letter B. Letter C, we've already talked about it there. All right, this is problem 6-103. If you still have questions, make sure you ask your teacher. Otherwise, good luck. Thanks for watching.